Friction acts between two surfaces whenever there is a relative motion or a tendency of relative motion between two surfaces in contact. The type of friction in the first case, when relative motion is actually taking place, is called kinetic friction. And in the second case, when no relative motion is taking place but there is a tendency of relative motion, we say it's the case of static friction. So note this important point. Relative motion is not a necessary condition for a friction to be acting. So what is tendency of relative motion? It simply means if there was no friction, some sort of relative motion would have taken place. Static friction is just there to stop this relative motion. Hence, while the block is static, there is a static friction which is stopping it from slipping due to a component of gravity. Now that we know what is static friction, we will start analyzing it in greater detail. Let's take a heavy suitcase lying on the floor and we are applying a mild force on it in this direction. The force is so mild that it is not able to move the suitcase on this rough surface. Let's look at its FBD. As the suitcase is in static condition, all the forces should be balanced. We say mg is balanced by the normal reaction by the floor, and the mild force we are applying is balanced by the static friction by the floor. Now we will increase the force a bit. The value of static friction will also increase to match the amount of force we are applying because it is still in static condition. Hence, the value of friction is always equal to the force which could have caused it to move in frictionless condition. Remember this important statement. This is almost always valid for a static friction. I repeat, static friction is always equal to the force which could have caused it to move in frictionless condition. But can the friction prevent this suitcase from slipping if we apply very strong force? No. If we keep increasing the force applied by us, there will come a point when the suitcase will start slipping. We say that at this point static friction has reached its limit. After this point, when the block has started to move, we say kinetic friction is acting on the suitcase and not static friction. Let's try to solve this problem. A small block is resting on a big block. If we pull the large block, the smaller block comes along. Which type of friction is acting between these two blocks during motion? And if we pull the bigger block with very large force, what will happen? Think about this. Let's first try to answer the first part. To find out which type of friction is acting on the above block, we need to first see whether any relative motion is taking place between the surfaces in contact. Here the keyword is relative motion. So though the top block is moving, its relative motion with respect to the bottom block is zero, as they are moving together. So it's clear case of static friction. Here there is a tendency of relative motion though, and we had already discussed that it is in this direction. So the static friction is acting in this direction on the top block. Let's look at the FBD of this block. What are the forces acting on it? They are mg, normal by the bottom block, and static friction by the bottom block. Are the forces balanced? No. We can see that the net force is in this direction. This force is causing it to accelerate in this direction. As we can see, these two blocks are moving together. Hence, if the bottom block is accelerating due to the force we are applying, the top block should also accelerate with it in the same direction. And that required acceleration is caused by friction. A very beautiful observation we can make over here is that here friction is causing motion of the top block. There is a normal perception that friction opposes motion. That's not true, as we can see here. The keyword here is relative motion. Here friction is opposing relative motion, and in that pursuit it is causing the top block to move along with the bottom block. Now the next part of the problem. If we apply very large force on the bottom block, it will have a very high acceleration. To keep up with the bottom block, the top block will also need to have a very high acceleration. We learned that this acceleration of the top block can only be caused by static friction. We had also learned that static friction has a limit. When the required acceleration to keep the relative motion zero becomes too high, the static friction is no more sufficient and relative motion starts taking place. Eventually, the top block falls from the bottom block.